Okay, so today let me talk about what is real first. Then after I talk about real, then I will also talk about what technology we use and how these technologies will change the GIS field. So real is maybe someone who came to the FOSS4G last year in Kosovo, maybe you know about real. I hope so because we also did diamonds also last year. But we changed the logo, we changed the brand, we're also trying to change everything about real. Till last year, real was just data visualization tool, which allows you to easily visualize the GIS data on web, and also you can share the map. That's what real could do till last year. But we're gonna change logo. That is because we will transform the value of real to the more broader area. So we have realized we made the data visualization tool, and many of our clients use the real to visualize data. They were very happy, but also they couldn't be happy enough. They said they can visualize data, but they have no way to manage the data. They have no way to process, convert data from what they have to what they need for data visualization. So we have realized real need to support not just visualization, but also data management, but also data processing, data conversion as well. So real was just application till last year, but now it's transforming from one application to the data platform. Real consists with visualizer, contents management system, and flow. And let me talk about the visualizer. So visualizer is a data visualization tool, and you can easily import your GIS data into the visualizer and instantly just visualize and publish as well. So sometimes, like maybe many of you use QGIS or any GIS desktop application, they are very powerful, but sometimes you don't have any way to share the map to someone easily. So React allows you to easily visualize data and publish the map on the web. It also has very powerful styling system. We respect 3D tile style language, so which is the style language that Citizen uses. That style language allows you to conditionally apply the color and also style to the features. We extended that style language to our real more. So now our real style language can support conditional styling for point, line, polygon, even 3D data as well. It also has plugin system, which is also very powerful. Imagine it's like a Chrome extension. Because it's a cloud-native application, everybody uses the same version of real, and it's very nice. You don't need to install. You just sign up and you can use it. But there is some drawbacks. That is because it's running on web, there is some limitation to incorporate your interface. A plugin system allows you to incorporate. You can develop some part. You can then import that extension we call plugin to a real. So we take the good part of the web and also solve the bad part of the web with plugin system. The next product is called Contents Management System. We call it CMS, which is a data management tool. So visualization is done by React Visualizer. So CMS allows you to easily manage the data. You can import many type of GIS data format to the Contents Management System, and you can also collaborate with your team members. So one example is our client, Plato. They are a team of more than maybe 100 people. They have each 100 people have their own account, and they will create the data of Japan, and then they will upload the data to the Contents Management System. So the administrator can also see what kind of data format is made by who, and also they can manage which data should be public or unpublished. So the way they process data is the administrator check all the data they want to have, then they just click the button to publish specific data. So it can be used for a foundation or open data platform. The next project is called Flow. So which is a data conversion tool. It's still under the development, and we're gonna try to finish the development within this year. I mean, by next March. So this will also come sooner. So Flow is visualizer could allow you to visualize your data, and Contents Management System (CMS) allows you to manage manage data. Our problem is we have so many kind of data format in GIS, like shapefile, GeoJSON, or 3D tiles, whatever. And then sometimes you have the data, but you need to convert data into the data format you need to use. That's a lot of pain. And sometimes you also need to process data, like clean up data and also do some analysis. That's a lot of work. So Flow will solve that problem. So Flow is the visual-based coding. So you can make own workflow to convert data into the other data format, or even analysis as well. And you can combine, for example, this example is you can aggregate attribute, you can also aggregate geometry, you can also join multiple data into one data format. And then you can export as the other data format. For example, in the example of Prato, they have CityGmail data. CityGmail is very powerful data format, but also not suitable for web. So they have the CityGmail data, they convert that data into the 3D tiles, which is more optimized for web use, and then use that data for visualization. That's how they use Flow. So this is one example of the Plato. So this project is running on React, and we have very beautiful like cities. Yes. And we also can have a height map, digital terrain model as well. Yeah, and not only building model, they also have vegetation model or natural disaster model or bridge model. They have so many type of features. And React can handle these many type of data. And also, we also take advantage of 3D computer graphics. So though this data is huge, but it can render very easily. It can even run on like normal desktop application. Yeah, React can be used for many cases as well. So one example was Plato, but also React is used for example, our analysis. That example is simulate the airflow in our area. So React was used to simulate from where to where the air flows, and then that could be used for urban analysis, urban simulation. And the government or local government can plan in which area they should have like high tall building, or in which area they shouldn't have. And also some example shows the natural disaster management. The river flooding is one of the biggest natural disaster in Japan. So the government spent much money to simulate which area will be suffered from flood. So React also can, because React supports 3D visualization, we can also see to which height of the building will be suffered from flooding. Okay, so I talked about what is React and what product we have. So next, I will also talk about the current state of web technologies and also GIS technologies. We believe in many cases, web or cloud native technologies is very advanced, and we believe that technologies can be incorporated into the GIS technologies as well. This is a problem we assume. We believe GIS has several problems. One example is massive data. Sometimes, like having, for example, the Prado case, they uploaded more than 10 terabyte or 20 terabyte size of data into a content management system. Having 3D GIS data would be result in huge file. Also, sometimes vendor will be also a problem. So some company make own data format, and the data format itself is open, but software of them is not open source. So they try to promote their data format, try to standardize the data format, but that will be resulting profit of the company. And many of the developers will struggle with handling many of data format. And also limited access speed. So we believe the advanced technology of web technology will solve this problem. We use these technologies like React, TypeScript, WebAssembly, and for backend language, we also use Go and Rust. This language technology is now very standard in web application, but not that common in GIS. So we believe using the technology solve a lot of problems for WebGIS.
So for example, one example is use of WebAssembly. React also use WebAssembly for the for programming system. And how does WebAssembly solve this problem? So there is some limitation in the JavaScript because we need to use JavaScript for browser because that's the only language. But the JavaScript is not it's easy to write, but not that performant compared with C, C++, or Rust. So WebAssembly allows us to have a secure runtime and also faster runtime on browser. And yeah, there's also some limitation for GIS tasks. So for example, it's not easy to do analysis on browser, I mean in terms of the WebGIS. And also it's not easy to handle large scale data. And sometimes the map, like rendering the map on the web, especially using WebGL, is sometimes slow. And yeah, and some map engines, some web library doesn't support cross-platform. We need to make application for web. We need to make application for native application. But WebAssembly is the standard, can be used for not only web, but also as long as it's compiled for a WebAssembly, it can be also used for sometime backend runtime, can be sometime run for the other environment as well. Yes. Yeah, so we believe not only WebAssembly, but like the new technology like WebAssembly or new programming language, new technologies invented web application, web cloud native like communities would solve a lot of problem of WebGIS. Let me also talk about vendor lock-in. Yeah, as I told you, sometimes the company try to make own data format as open data, but also try to keep their software as a private. But luckily, React, we publish all software as open source, so everybody can access to React source code. So technically, everybody can use React. That's what we try to do. Yeah, so we have so many benefits of open source. We believe the power of open source, not just collaborate together, but also it's very beneficial for our community as well. And that's also one reason why Japanese government decided to use React, because React is based on open source and the source code itself is public. So even, for example, we fail or even something happened to us, but the product can be still maintained by community. So we take advantage of open source, and that's why we also try to contribute to the open source community as well. And there's also some perspective of digital public goods. So not as open source, the digital public goods is the idea to make the public goods can be used for anyone. So there is some definition for that, and we try to make a React as digital public goods. So for example, open source or open access. So the data and also source code should be accessible for anyone. And also privacy protection and security should be respected as well. And contribution to the SDGs. And also that will encourage the international collaboration and innovations as well. Yeah, so finally, I also talk about limited accessibility. So there is some limitation, so allowing everyone access to the React. So one was some GIS application was really hard to use for non-technical people. So only GIS expert could use the GIS software, but React tried to overcome this problem by providing very nice UI and also intuitive UIs. So our designer tried to explore the very nice UI, so any beginners can also use our product. And yeah. So there is some key focus area in React. So one is no code or low code accessibility. That's what we try to do. So originally, our company started to make a digital archive, but the reason why we decided to develop the React is many clients and many users ask us to develop the map for them. And every time we develop use the system, we every time use did many coding to develop their map. But then we came up on what if we can have the no code tool that user doesn't need to coding, but they can make the map. That was the original idea why we decided to develop the React. So that is the fundamental philosophy we have. We try to make this difficult part as no code or low code, so the user doesn't need to know how to do coding, but they can make the map, they can do processing the data, they can also make the data as well. And fully web-based, there are many desktop-based applications, but using the web, we can collaborate on web. That's the big advantage of web. So we believe web technology and also allowing GIS technologies run on browser, run on web, reveal a lot of possibilities. And also extensibility. So as I talked, React has plugin system, and CMS also has a system. It's called integration, which allows your application integrate with CMS. Flow will also support plugin system. So the idea is, we're based on web. We try to get advantage of running on web, but also want to solve the drawbacks of web, which is the extensibility. But we have extensibility, so we try to allowing you to extend our web application to your case as well. Yeah, so yeah, there's high demand for combination of web and also GIS skills. The note about the GIS product, actually our activity as React team and making our product as open source made many cases. So the product can be used for civil engineering or web engineering, city planning, and yeah, the product requires many of the skills. And our activity has the technology of GIS and also having the scheme as open source, and also purpose is we can also make the job for people. So this is one example of our colleagues. So she has some very difficult background. So for her, she has a knowledge of web development. She knew about web technology, but she didn't have a job. And she had some difficult situation because of some political reason or because of some external factors. But because we work online and our source code is open source, so all of our colleagues can contribute to the React project, and finally we could also give the job to her as well. So she was so happy to have the job, work as a career, but also contribute. Through her job, she also could contribute to the OSS community. That's the power of open source. So open source is sometimes sounds like a charitable project, but also making open source product as a business has a powerful power, giving the job and giving the opportunity that all colleagues can contribute to the open source. So this is our future work. So currently we have Visualizer, and CMS will be released in sooner. So we plan to release the latest version of Visualizer and also CMS in next year, and the Flow will also come sooner. So yeah, I hope you will enjoy this product. Yeah, so finally, we also hope to have FOSS4G Japan in 2026. So I hope you will come. Thank you. Yes, it's completely opposite side of Brazil. We have 12 hours difference, but I hope you will come to Japan at that time. Yeah, so in conclusion, the evolution of the web technology will also develop a lot of possibility of GIS technology. So we believe having the web idea, having the technology made from web industry, bringing that technology into the GIS will result in very amazing technology in WebGIS. Okay, so also we would like to thank you for our FOSS4G community. We could do sponsor for Kosovo last year, and also we could do sponsor for Belém as well. So we're also proud of sponsoring to the FOSS4G OSS community. Thank you. And this was only 30 minutes presentation. So to know more about Rears, we have website. We also have GitHub. Of course, it's open source, so you can have a look at the source code as well. And also the company Eucalia. So please have a look at our website. Yes, and as a sponsor, we also have many talks yet. So we have a talk about Rears Visualizer. That'll be tomorrow. We also have a talk about Rears CMS and the Flow, which is today. And we also have another talk about the Navalo, which is a map engine. We also currently developing the map engine instead of SISM, or to solve the current problem that current map engine has. So we still have 3 talks, and we will talk more detail about each product and technical aspect. So if you have any interest, please come to this talk as well. And we also have booth just there. If you have any interest in a product, please come to the booth. Okay, thank you.